All right, let's have a look on question 2. The question 2.1 is asked you for that. Okay, explain with the reference to the property principle, which way were the currents were traveling when the coil rotates 90 degrees but anti-clockwise. All right, let's say Hattie, what is your idea for that?
As the coil rotates 90 degrees, the coil will be further from the south pole and experience a weaker magnetic field strength to the left. According to Lenz's law, a clockwise current will be induced to generate a magnetic field strength towards the left in order to counter the change in magnetic field strength.
Yes. All right, you can do it that way, but if the question label you X and Y, I would recommend you to say like either X flow to Y or Y flow to X, because clockwise and anti-clockwise, it depends on which side we view the coil. Yeah, but you might say like X to Y or Y to X. It might be more details when you go through between those two. Since like if you just tell something like clockwise or anti-clockwise, it might be depends on which view you like view the coil. That's what it's on. And the question tells you two corner has already been labeled to assist you. Kind of tells you like you're using those two corners to do either X to Y or Y to X. Okay, all right. So exactly, you would say like as the coil rotates anti-clockwise, you want to tell them when they rotate anti-clockwise, what has happened? The flux from right to left is increasing, right? They do have more flux, which is from left to right. So right to left. All right, if the flux from right to left to increasing, you would then say, okay, according to my Lenz's law, I need to produce a current. The current produced from the loop will create something to reverse that. So that's why they were saying they were created opposite B fields, opposite flux of B fields, which is from left to right. All right. And then based on my right hand reproof, if I want a coil, I want a B field which is from left to right when I be 90 degrees. If I want something to left to right, which means you will exactly flow from X to Y, and then it is exactly go clockwise if you view from the north pole, from the south pole. But I would still say like the current is flow from X to Y. It might be more detailed for you. All right. How to view that? You might try to use something to like have a try by yourself. After they rotate anti-clockwise, I will have my X and Y in the bottom of the corner. So this might be Y and the other one is X. So that's why when I have my thumb is pointing to the right, you guys will have from Y to X and then go to the top. So try to visualize this. Induced current just be current, but it's just like the current induced like by someone else, like by the theory.
It's called any current, right?
Any currents. Oh, you can call eddy currents. You can call them as eddy currents. You can.
Oh, okay. Yeah, I'll just clarify.
You can call them as eddy currents. No, they're the same thing. But it depends on scenario. Sometimes like you have a scenario, maybe like we have the normal current flow in this whole scenario, but I still have the eddy currents, which is produced by this like Lenz's laws themselves. Yeah, but in our cases, like if I just specifically try to mention on my Lenz's law and Faraday's law, I will just call them as induced currents. All right, so here's question A. First period. Question B asks you identify 3 ways that the EMF of the AC generator can be increased. All right, Alan.
I could number of increase. Speed of the coil in magnet.
Yes.
And strength of the magnetic field.
Yes, exactly. Since this one just like based on my formula, EMF equals to negative n number of turns over time. So you guys can either increase number of turns or increase my B field strength, like magnetic field strength. Finally, you can decrease the period, or you can increase frequency, or you can increase like the rate, like the speed of rotation. But those three, they're only being counted from one box because they can't say the same thing. So you might to tell them what is the actual two methods to be. Alright, and then question C, on the EMF graph, try to draw the new EMF if my frequency is doubled. Sean? Okay. And then frequency is double, which means what is my x-axis? The x-axis is my time, which is periods. So frequency, if you double them, you are exactly half the periods because they have the inverse proportional relation between each other. Right. This is this one we learned this one like a long time before when we learned like circular motion or something else. They are exactly two different definitions. And yes, you do increase your amplitude, but you also decrease the period. So you might draw some curve like this for me, which is I have already half of my period, and I do increase the amplitude. It is because EMF it is equal to negative n and number of turns. So if the time is being half, the EMF will exactly become double. So that's why be careful when I change those like period, frequency, always need to change either x and y axis. Alright. And then next one, determine the peak to peak voltage when the frequency is double. Alright. Let's say, Haixin, what is your idea for question D?
The peak to peak voltage would it double as well?
Yes. All right. So
it become
become what?
4 volts.
All right. Yeah, I know your idea is, but the question is specific asks you when the frequency is double. So kind of they ask you to solving out the voltage, but it is in the new scenario. So that's why I do believe if you see the scenario you draw before, the peak value is 4 volts, and the peak to peak, it is 4 times by 2, it is 8 volts. Because they ask you to refer to the frequency when it is double, that's the new graph you draw right now. Question E, I try to clarify this. This is the thing I said. The question said, calculate the equivalent EMF that a DC battery will produce in order to produce the same voltage as is calculated in part D. So kind of tells you they just ask you to solve out the RMS value, because the RMS value, it is the average value for AC, and you can use this one for DC as well. If for now you want to make the DC battery, they will produce the same average voltage as my AC. So finally, just using your peak divided square root 2, you will then have 2.83 volts as your final answers. All right, finally, figure out the difference between DC motor and generator. All right, this is something we said before. Oh wait, what is that?
So I said DC is the ring motor.
And they ask you for motor and generator. They not ask you like DC and AC. Yes. It's okay. You guys will say like my DC motor is something what do I use? I use electrical energy into kinetic energy. And the generator is I'm using kinetic energy back to electric energy. And okay, we just leave it over there. So this is a general idea, but if the question also function, I'll just tell you guys how to describe this one as this. So just first get an idea of how can I, like the basic difference between multiple and general in these scenarios, which is one is electrical energy to kinetic energy. The other one is kinetic energy go to electric energies.